When we studied linear functions, we found that there were three different forms of a linear equation that we were particularly interested in: standard form, point-slope form, and slope-intercept form. And each one of those had its purpose. For instance, slope-intercept form was great when we were trying to quickly graph a linear function. We're about to find out that there are several forms of quadratic functions as well. We've already studied standard form. Today we're going to look at two more. We're going to look at vertex form and intercept form. So beginning with vertex form, it looks like y equals a times the quantity, x minus h, that quantity squared, plus k. Again, a gives us some information about the shape of the graph. When that a value out in front of our quantity is positive, the graph opens up. When that is negative, the graph opens down. Our steps for graphing from vertex form are going to follow the same pattern that we followed for standard form. We're going to go ahead and find our axis of symmetry and draw it in. We're going to plot our vertex. Because we've done that, we've front-loaded the work. Now we've created a situation where we know we've got symmetry on our 5 points in our table of values, so we only need to locate 2 points right of the vertex and mirror those over 2 points left of the vertex, and we'll be good to go. So let's take a look at how this is going to happen. For the function y equals 1/2 x minus 3 quantity squared minus 5. There's our form, y equals a times x minus h quantity squared plus k. I can see x minus h and x minus 3. My axis of symmetry is the line x equals h. So I can see that my axis of symmetry for this graph is going to be the line x equals 3. I'm going to go ahead right to my coordinate plane and draw on a dotted line that represents my axis of symmetry. My vertex is laying right there in front of me in the equation when it's written in vertex form. It's the point HK. And so we know that our vertex lives on our axis of symmetry. Its x-coordinate is going to be the same as the axis of symmetry. So that's the point 3, the k value. Now this says minus 5. Our general form says plus 5. Keep an eye out here. Look what happened. We had 1/2 x minus 3 quantity squared plus a negative 5. So my y value for my vertex is going to be negative 5. Similarly, had this been x plus 3, we'd had to think about it being x minus negative 3. Keep an eye on your signs here. So now that we have our axis of symmetry and our vertex, it's time to make a table of values. I know that my vertex happens when x equals 3. The y-coordinate is negative 5. Now I need to fill in the rest of these values. 2 points to the left of my axis of symmetry, 1 and 2. 2 points to the right, 4 and 5. Now our job is to go in and find the y values that go with 1 and 2 and 4 and 5. Because we've front-loaded the work, we know that the values for 1 and 2 are going to be the same as the values for 4 and 5 because of symmetry. So we only need to calculate 2 of these. I can either do 1 and 2 or 4 and 5, but I don't have to do all 4. Most people like to work with numbers that have a smaller absolute value. So let's go ahead and use x equals 1 and x equals 2. So when I plug 1 in, (1/2) of 1 minus 3 squared minus 5. It's half of negative 2 squared minus 5. Half of 4 minus 5. Which will equal negative 3. So when x is 1, y is negative 3. Similarly, when x is 5, y is negative 3. So let's plot those points. I can see at this point is 2 units left of the axis of symmetry. I'm going to have another 2 units right of the axis of symmetry, which just happens to be 1, 2, 3, 4, 5. 1, 2, 3, 5, negative 3. Now we go back and let's insert in 2. So f of 2, I have half of negative 1 squared minus 5. So 1 half minus 5, negative 4 and a half. Now that I've got my 5 points, I can go ahead and plot a smooth curve through those points. And I've graphed a parabola from vertex form. Let's move on now and take a look at the graph of a parabola in intercept form. It sounds a little bit complicated. In fact, if you take a look at the steps included in the notes, it looks pretty challenging. So let's just avert our eyes for a minute. If you remember from Algebra 1, solving quadratic equations by factoring the quadratic expression, this should look very familiar to you. Y equals x minus 2 times x plus 4. I'm going to go out on a limb here. I'm going to say that this is telling me that there's a point on this graph at negative 4, 0, and a point on this graph at positive 2, 0. In addition, that tells me that my axis of symmetry is going to live at x equals negative 1. Now I still need a little bit more to fill out this graph, but I think the bones here are pretty good. Let's take a look at what happens when we have a graph in intercept form. If the graph has at least one x-intercept, the function can be written in intercept form, which is y equals a times x minus p times x minus q. In other words, a binomial product. And again, when a is 0, the parabola opens up. A is negative, the parabola opens down. And this part is important. The p and the q, those are going to represent the point on the graph, as we just showed here. Let's follow the steps from our notes. Axis of symmetry is the average of p plus q. So let's see what we've got here. Here I can see my p is 2. My q is negative 4. X minus q, this is x minus negative 4. So 2 plus negative 4 is negative 2 over 2. My axis of symmetry is negative 1, just as we guessed over here. What about our vertex? Well, unlike vertex form, and like standard form, we actually have to go in and substitute in our x value to locate the y coordinate of our vertex. So we know that our vertex happens at negative 1. So let's find f of negative 1. Negative 1 minus 2 times negative 1 plus 4. That's negative 3 times positive 3. That's going to be negative 9. 1, 2, 3, 4, 5, 6. 7, 8. We'll call it about right there. Okay, so we've got a vertex. Let's go ahead and fill in our table of values. Our vertex happens at negative 1. 2 points to the left. How about negative 3 and negative 2? 2 points to the right, 0 and 1. Now, ever since we took a look at standard form, we've been waiting to have a 0 here because we knew that the y coordinate, the y there, will be our y-intercept. Right? But look, we don't have a c value here. So we don't catch that break, but it'll still be easy to work with 0 and 1. So let's use those. F of 0. 0 minus 2 times 0 plus 4. Negative 2 times 4 equals negative 8. So when x is 0, y is negative 8. Similarly, due to symmetry, when x is negative 2, y is negative 8. So let's plug those points in. About those 2 points right there. Now let's go back and do f of 1. One minus 2. 1 plus 4. So I have negative 1 times 5, which is negative 5. So when x is 1, y is negative 5. I moved my vertex over here. Let's fix that. And when x is negative 3, I have negative 5. All right, so now I've got points that are on my graph. That one's a little wobbly, but it'll do. This is the graph of y equals x minus 2 times x plus 4. Just wrapping things up, we wanted to go back and revisit the idea of a minimum or maximum value of a graph today. Your a value is going to tell you what you're looking at, a graph that opens up or opens down. Here a is less than 0, therefore this graph opens down and has a maximum. In number 2, a is greater than 0, therefore this graph opens up and has a minimum. Now we're also asked to find the minimum value. Remember, the minimum value is just the y-coordinate of the vertex. In this case, our example just above with the intercept form, we can see this opens up. This is my minimum value. It's the y-coordinate of the vertex, which is negative 9. So let's make that happen. We need an axis of symmetry here. This is vertex form. Negative 6, negative 12 is the coordinates of my vertex. The y value is negative 12, so my minimum value is negative 12. So vertex form, finding your minimum, is pretty cut and dried. Let's take a look at how that works in intercept form. So remember, my axis of symmetry is going to happen at x equals p plus q over 2. My p is 3. My q is 6. That's the value 4.5. To locate the vertex then, 2 times 4.5 minus 3 is 4.5 minus 6. 2 times 1.5 times negative 1.5. 2 times, we could actually multiply right on through. 2 times 1.5 is 3. It's negative 1.5. I'm going to have negative 4.5 for my minimum value. So that's a look at graphing from vertex form and intercept form, and also calculating our maximum or minimum value of a function.